Welcome back. This is the last and final video on the series of videos on the topic of substitution and elimination reactions of alkyl halides, right? So I want to finish it up with two more examples and then the flow chart that I've mentioned you all earlier about. All right, now the first thing you look at in the first example is the base itself, and that's a weak base. Okay, and this is a polar protic solvent, right? A polar protic solvent highly favors an SN1 or E1 reaction, especially when it's a weak base. The fact of the matter is this is not a very bulky base. We can expect an SN1, okay? So this is a tertiary alkyl halide. I'm gonna switch pencil here actually. Okay. So this is a tertiary alkyl halide, and knowing the fact this is a weak base and a polar protic solvent, we can expect an SN1, okay? Looks like that is not working. It's not the pen I would really want. Okay, let's go with this. So this is a SN1, right? So what happens in an SN1? The leaving group comes off first, leading to the formation of a carbocation, right? So let's get a different color. So the leaving group comes off first. Okay, let me redraw this. Okay. So this is a tertiary carbocation, right? Now the nucleophile is going to come into place. So what happens now here is you see your methanol, which is your base, right? And you got this, right? So the lone pair attacks this carbon. If you remember our SN1 mechanism from the previous video, the lone pair attacks the carbon containing the tertiary carbocation. I'm going to switch colors again, just for clarity. So what happens now is we have we still have the hydrogen, but the fact of the matter is the positive is now moved to the oxygen because the oxygen has lost a pair of electrons to make that bond, and you still have the CH3, right? Now this is an intermediate. This is another step in the process. Now what happens here is another base that's sitting by somewhere, Okay, this comes and grabs this proton here, okay? And in the process, the bond comes back to the oxygen and gives it that lone pair that it lost. So what happens in the process is, so you get your final product, which is, this is of course the mechanism which you would always use, right? So basically, get rid of the Br and put in this group right here in place of that, right? This is a bond connecting the OCH3 to this carbon right here. So this is your final product if this were to be SN1, okay? Now here, this is also a weak base, but this is a really bulky, weak base. And it's also got heat, which is a clear indication that this is going to be an elimination reaction, in particular, an E1 elimination reaction, right? So what happens here is, this is again a two-step process. So the Br comes off, which gives us positive charge, a carbocation, which is the same as the one above. You can see this is the same molecule. So you will generate the carbocation in both the cases because we figured it's a E1. This is SN1, this is E1. Why? Because of the heat and a bulky weak base, right? So now this is the carbon containing the leaving group. So it's alpha. So this would have been the beta. But because this side contains this molecule, it's difficult for this bulkier group to come this side and grab this beta hydrogen. So it's going to come and grab this hydrogen, which is the beta hydrogen here on this carbon. So this is CH3, CO minus, right? That's what comes and grabs this hydrogen, and in the process this comes down here, and in the process it generates a double bond. Okay, so this is an E1 product, this is an SN1 product. It all changed because of the nature of the base that we use. This is a weak base, that's also a weak base, but this is a small size weak base, this is a large bulky weak base, and of course heat also made sure that it goes through an E1 process relative to an SN1 process, right? All right, here's the flow chart I was talking about. So first thing you look at is the base or nucleophile strong? If it is S, then you at this point you have an equal chance of an E2 or SN2. Okay, at this point you can't really decide that, right? You keep going. You just assume it's E2 or SN2 or both at some point is possible, right? If the base is weak, that means it's not strong. It's what the question is asking. That means the base is weak. Then you have an E1 or SN1 probability, right? So if you decide to go E2 or SN2, means it's bimolecular. That means the 2 stands for that it depends on both the concentration of the reactant and the nucleophile. And then you go down further in the line, is the nucleophile or base, which is strong, is it bulky? Okay, if it is yes, that means you go to an E2. If the answer is no, what is an example that I gave you for this? The example I gave you is CH3, CONA. And this is negative, this is positive. This is bulky. If it is bulky, that means you go through an E2 mechanism. If it is not bulky, then what kind of substrate? If it is a tertiary substrate, then you can be guaranteed that, say you have a strong base, okay? Okay, this is not bulky, but it's still a strong base. And say you have a tertiary substrate, okay? What is a tertiary substrate? A carbon substrate containing 3 bonds and neither of them are hydrogen, right? In that case, you would go to an E2. If the substrate is secondary, then you have a 50-50. Okay? Say the substrate is primary, then a strong base can only result in an SN2. Okay? You are on this side now. You at the start you decide the base is not strong, it's rather weak. Then you can have an E1 or SN1. If the base is bulky, like the one I showed you earlier, which is CH3, COH, right? This is a bulky base. So if your base is weak but it's bulky, then you do an E1. If your base is weak but it's not bulky, then you do an SN1, okay? This, again, we are using, assuming it's polar protic, okay? Then E1 and SN1 are highly possible. I've already mentioned that to you earlier when we talked about solvents, right? Now, this really simplifies the entire concept, okay? You are going to get it right most of the time, but again, you still have to go ahead and go through the mechanism, whichever one you choose, to get the desired product, okay? Now, from an exam perspective, I could give in a multiple choice where I could give in some mechanisms and have you pick the correct mechanism based on the reaction conditions, such as the nature of the substrate and nature of the nucleophile, which is base, which is strong or weak. All right. Now, I don't want to say any more to complicate this topic. This is where I want to stop this topic. And then I would recommend you watch all the videos and do every single problem that I give you in class. And if you have any problems at any point on any of this that I've covered, either the reactions themselves or the flow chart or the bases or the solvent, just ask me as we do some of the worksheets. All right, so stay tuned for more videos on a completely different